Unleashing AWS Lambda, your guide to serverless mastery. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction to Serverless Architecture and AWS Lambda. Serverless architecture represents a paradigm shift in cloud computing, allowing developers to build and run applications without managing the underlying infrastructure. AWS Lambda, a key player in the serverless ecosystem, enables the execution of code in response to events, automatically handling the infrastructure concerns. This model empowers developers to focus on writing code, improving productivity and innovation. Benefits of AWS Lambda: scalability, cost-effectiveness, and developer focus. Scalability. AWS Lambda automatically scales your applications by running code responding to each trigger. Whether you have a few requests per day or thousands per second, Lambda adjusts seamlessly to your needs, ensuring consistent performance without manual intervention. Effectiveness. With AWS Lambda, you pay only for what you use. There are no upfront costs or charges for idle time. Billing is based on the number of requests and the execution duration of your functions, making it an economical choice for a wide range of applications. Developer focus. Lambda abstracts the complexities of infrastructure management, allowing developers to concentrate on code and business logic. This fosters rapid development, experimentation, and deployment, accelerating applications' time to market. Getting started with AWS Lambda: setting up and creating your first function. Sign into the AWS Management Console. Navigate to the AWS Lambda service. Create a function. Click Create Function and choose a blueprint or author from scratch. Configure the function. Provide a name. Select a runtime. For example, Node.js, Python, and set execution rules for permissions. Write the code. Use the in-console editor or upload a zip file containing your code. Test the function. Create a test event and invoke the function to ensure it works correctly. Invoking AWS Lambda functions through diverse triggers and event sources. AWS Lambda can be triggered by various AWS services and external sources, making it highly versatile. Common triggers include API Gateway, create RESTful APIs. S3, respond to object uploads or deletions. DynamoDB, handle data streams. SQS, process messages from queues. CloudWatch events, schedule functions based on time. AWS Lambda use cases, orchestrating microservices and real-time data processing. Orchestrating microservices. Lambda excels in a microservices architecture by decoupling complex applications into manageable, event-driven functions. Each function can handle a specific task, enhancing modularity and maintainability. Real-time data processing. Lambda's ability to process data in real time makes it ideal for applications like log analysis, IoT data processing, and streaming analytics. It can seamlessly integrate with services like Kinesis and Firehose to ingest and analyze data on the fly. Streamlining API development with AWS Lambda and API Gateway integration. Integrating AWS Lambda with API Gateway simplifies the creation of scalable APIs. API Gateway is the front door for applications, routing HTTP requests to Lambda functions. This combination provides a powerful, serverless way to build and deploy APIs, with features like rate limiting, authorization, and API versioning. Best practices for building efficient and cost-effective AWS Lambda functions. Minimize package size. Reduce deployment package size by excluding unnecessary dependencies. Optimize memory allocation. Allocate appropriate memory based on function requirements to balance cost and performance. Roost database connections. Implement connection pooling to avoid the overhead of establishing new connections. Avoid cold starts. Keep functions warm using scheduled events or provisioned concurrency. Deployment and monitoring strategies for AWS Lambda functions. Deployment. Use infrastructure as code tools like AWS CloudFormation or AWS SAM for consistent and automated deployments. This approach ensures that your Lambda functions and associated resources are reproducible and version-controlled. Monitoring. AWS CloudWatch provides insights into Lambda performance through logs and metrics. Set up CloudWatch alarms to monitor critical function metrics and receive notifications for threshold breaches. Optimizing AWS Lambda performance, code efficiency, cold starts, and resource allocation. Code efficiency. Write efficient, clean code to reduce execution time. Cold starts. Mitigate cold start latency by optimizing the initialization code and using provisioned concurrency for critical functions. Resource allocation. Monitor and adjust memory and timeout settings based on performance and cost considerations. Understanding AWS Lambda pricing. Pay-as-you-go and free tier benefits. AWS Lambda offers a cost-effective pricing model with two key components. Request pricing. Charged per million requests. Duration pricing. Billed based on the execution time in milliseconds. The AWS free tier includes 1 million free requests and 400,000 gigabytes to seconds of compute time per month, allowing you to experiment with Lambda at no cost. Conclusion. AWS Lambda, a cornerstone of serverless innovation. AWS Lambda has revolutionized how we build and deploy applications by providing a scalable, cost-effective, and developer-friendly platform. Its ability to handle diverse workloads, integrate with numerous AWS services, and eliminate infrastructure management makes it an essential tool for modern cloud applications. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.